This is the virtual hospital we are building on University of Arkansas Island in Second Life, a 3D multiplayer virtual world. As you will see as we tour the hospital, it contains the usual things: beds, wheelchairs, medical equipment. In many Second Life worlds, the focus is on imaginative buildings, castles in the sky, or beach houses. In some other work on Second Life hospitals, the focus is on training or architecture. Our project's focus is on a hospital of the future and on explaining and exploring ubiquitous computing. Our hospital is fully instrumented with smart networked objects and with virtual radio frequency identification, so we can track where everything is as it enters a complex supply chain from warehouse to arrival at the hospital to storage room and on to patient use. As avatars or items move through our hospital, their positions and status is tracked, so nurses can always find the resources they need. Access control assures that avatars only access areas they are allowed in, and the patient cannot take the wrong medication. In what follows, we describe our virtual RFID, how avatar bots can perform complex workflows, and some of the kinds of smart equipment we have built. We also describe work by high school students working with our project, building a second hospital on the Teen Grid on the East Program Island in Second Life.
The system you are about to see is an overview of the basis of our project, the RFID sensor network. All of the red fields displayed across the hospital are various RFID scanners. These scanners operate on LSL script-based RFID tags in a similar manner to real-life RFID systems. The small sphere on the ground in front of the doors is an RFID tagged object. Each of the two vertical towers is an RFID scanner with its own discrete range. You can see each range reflected in the red fields. Anytime an object containing an RFID tag script passes through a field, the associated scanner detects and parses the object's tag. From here, the scanner is capable of a large variety of actions, from placing the object's information into a generic database to updating location, quantity, ownership, identity, and other encoded information within a database-driven system tracking the hospital's assets and personnel. This means that every tagged item, person, and piece of equipment in the entire hospital is trackable and findable in real time from any networked computer system.
Our supply chain scenario begins as an avatar drives a truck up to the warehouse. The avatar exits the truck and then enters a code into the security keypad to open the door. The avatar then accesses a heads-up display device which is networked to communicate with the warehouse. An order is entered, and then a command is given to send the order to the warehouse and have it pick the order. The avatar then packs the cases onto the smart pallet, which scans each case as it's loaded. After all the cases are loaded, the avatar accesses a listing from the pallet to verify the order. The pallet is then loaded onto the delivery truck, and the avatar begins driving the truck to the hospital loading dock. The delivery truck is also able to scan what has been loaded onto it. So after the truck has been backed up to the dock, the avatar will be able to access a bill of lading report from the truck. Finally, the avatar issues a command for the delivery truck to unload the order onto the dock. From this point, the internal supply chain kicks in and a resupply robot takes over. An avatar issues a command for a robot to begin executing a program to scan for newly arrived orders at the dock, taking the pallets to a designated storeroom. The robot works with a transponder sensor network and path server, utilizing waypoints to navigate through the hospital. This allows it to avoid obstacles as it performs pre-programmed tasks. After the pallet is delivered, the robot returns to the dock to see if there are any other items waiting to be moved. Another supply problem in our simulation involves the secure handling of prescription drugs. The scenario begins with a doctor and patient sitting at a consultation station which can scan them to verify identity. Only an avatar registered as a doctor has access to the system where patient information, including prescriptions, is recorded. After gathering the patient's information, the doctor writes a prescription and diagnosis for the patient. The information is recorded in the database, making it unnecessary for the patient to deliver a handwritten prescription to the pharmacy. The patient now makes his way to the pharmacy, but in this simulation, a smart wheelchair can be used to deliver patients around the hospital. This delivery system utilizes the same sensor network and path server to determine the best route to the desired location. After receiving a command for a particular location, the wheelchair follows a series of waypoints, ultimately delivering the patient to the pharmacy. This pharmacy utilizes a smart prescription filler dispenser which recognizes a patient and can access the prescriptions on file. After the patient chooses a prescription to fill, the device delivers the prescription in a sack ready to be purchased, but only the patient is allowed to buy it. The patient buys the prescription and then carries it out. Later on, the patient opens the sack to reveal a smart pill bottle. This also causes the prescription information to be displayed. The pill bottle senses the identity of the avatar touching it and will only dispense a pill if it senses the patient. In this virtual world, avatars don't normally get sick, so prescriptions can do more than just deal with disease. It is a happy pill, and after taking it, the patient responds accordingly.
Many Second Life worlds are pretty quiet, and not much happening. That is true of ours at present, but not for long. Shown here are our first avatar bots in a little vignette. An avatar bot is an avatar that is driven by a program rather than a person. A patient bot is in pain, and a nurse bot visits the pharmacy to retrieve a medication. Presently, this happens in a loop, over and over. In the future, picture the hospital bustling with activity as patients arrive and operations are performed.
The other